Today's lesson is going to be on same base division. This is actually called the quotient rule. The quotient rule, and a quotient is kind of a big ugly word. Quotient is what we get when we divide things. So the quotient rule has to do with division. And just like the product rule, where it only applies when we have the same base, the quotient rule only applies when we have the same base. So if we are just going to look at this rule, it is a little more involved because when we are dividing the same base, and a nice way, and I always tell my students, if you see division written in a horizontal form, then just change it into the vertical form, a fraction form, because remember that fraction line means to divide. And when we get to more complicated algebra, we're not going to really write it this way as horizontal. We're actually going to write it this way as vertical. And so that's something just to keep in mind. So we don't want to keep it this way. We want to look at it like this. And basically, there's two scenarios we look for. If your m value, so if the power is greater at the top, then your base is at the top, and we say base A m minus n. However, if the power is greater at the bottom, then we have to put the base at the bottom. So remember, to put it at the bottom, we have to have a 1 over, and then we will go n minus m because we want to go bigger number minus the smaller number. So the base will always go where the power is greater, okay? So here we have same base division, and it's written in a horizontal format. So we're going to change that just so that we can see things better. And when we do that, we're going to get, I'm just going to rewrite it in fraction form. And now I can see the power is greater at the top, so my base stays in the numerator, so at the top, and I have to go 4 minus 2. And we know that that is then going to give me 5 squared. Now, if the question said to evaluate, then we would go one step further and we would give what 5 squared is. And you should by now be able to work out your power 2 and your power 3 for most numbers. So 5 squared is 25. So this step here we do if the question said to evaluate. So if we had to evaluate, that's where we would go. Okay, so let's look at this one here. Again, it's written in a horizontal form. So we're just going to change this and put it in fraction form. And now we can see that my power is greater. So I've got a power 3 and a power 2. It's greater in the denominator. So that means that we are going to write this with the 3 in the denominator. So the way we show that 3 is in the denominator is we have to put a 1 in the numerator. And now we're going to go 3 minus 2, which is 3 to the power 1. But remember our invisible 1. So the invisible 1, just as a reminder from our last lesson, the invisible 1 exists when we have a number to the power 1. We actually don't write it that way. We write it just by itself. If we have 1 of something, we don't write the 1. We just write it by itself. And when we have also another invisible 1 happens when we have a number over 1. So if I have just the number 4, it's actually 4 over 1, but we don't write that 4 over 1. We just write it as the number 4. So those are all examples of invisible ones. So just as a reminder that when you subtract your exponents, if you get a power 1, we don't write that 1 up there, but we know that it's there. Okay, so that's important for us to remember. Okay, so now we're going to look at this one. Now here, they've actually drawn it for us in fraction form. So we're going to go B, and then it's the power is greater at the top. So there's 7 and 4. So 7 is a higher power. So we're going to go 7 minus 4, and then that will give us power 3. Just to remind you, just like when we were doing product rule and we had to add, and I explained that you don't need to show the addition, you can just go straight to here. It's the same thing. In this problem and in the previous problems, you don't have to show me the subtraction. You can do the subtraction in your head and just get to the answer. I'm showing it here so that you understand where that 3 came from, okay? All right, so now we have another one. And in this scenario, we have power 3 at the top, power 9 at the bottom. So power 9 is greater than power 3. So we're going to go 1 over. And then my base stays the same. And then it's 9 minus 3. And that will give us 1 over 15 to the power 6. This example might seem worrying because we have decimals, but it does not change anything for us. The base is our decimal, so that's what we're going to look at. We just look for the power, so we can see we have the same base. Remember, the exponent applies to what it's touching, and what it's touching is called our base. So this exponent is touching the bracket, and so the bracket says 0.5, and over here, the bracket is also 0.5. So we have the same base, and what we need to do is we are going to look at where is the power greater. So we have power 6 and power 4 greater at the top, so we're going to write 0.5, and then we're going to do 6 minus 4, which then gives us 0.5 squared. In this example over here, now when it comes to dealing with fractions, like was you're dealing with a compound problem like this, where I've got multiplication and then I have division, always simplify the top and the bottom before you deal with them. So what I tell my kids, it's almost like zoom in and look only at the top, and then zoom out and look at the whole problem. So at the top, we have 3 over 4 to the power 2, and then times 3 over 4 to the power 4. So that is same base multiplication. And when we work that out, we're going to get 3 over 4 to the power 6. And then we have our denominator that we haven't dealt with yet, and that's at 3 over 4 to the power 5. And now we can work that out together, and that then is same base division, and the power is greater at the top. So we're going to go 3 over 4, and then it's 6 minus 5. And remember, we do not write that power 1 because it is the invisible one. So I'm just going to write this here just to remind you of the invisible one. Okay. Now in question G, or example G, it looks a little bit different because now I have coefficients. If you look in these questions, we really weren't dividing coefficients. We didn't really have coefficients to divide. We either had numerals that we were dividing, or we had variables that we were dividing. But we still haven't looked at when we have a coefficient with a variable and we are dividing. Well, the rule is we're just going to divide the coefficients and then divide the variables. So if I look at my coefficients, I have 10 over 15. And 10 and 15, so I'm going to write my little thought bubble over here. 10 and 15 are both divisible by 5. That's the highest number that'll go into both. So I'm writing this down just to remind you. So 10 and 15 are divisible by 5, which means when I divide them, they will reduce to give me 2 over 3. Now I have to look at my variables, and I have positive 3 and then negative 4. So remember, you have to look at the whole number, right? This is positive 3, this is negative 4. A positive 3 is bigger than a negative 4, okay? Because any positive number is bigger than a negative number. So that means that my x is going to be in the numerator. And now I have to go 3 minus, but it's not minus 4, it's minus negative 4. And that is very important for you to keep in mind, that we don't have 4 at the bottom. We have negative 4. So you have to go 3 minus negative 4. And remember, in math, we don't show an operation next to a sign. We have to put those brackets there so that it makes sense and it looks neat. And now I can work that out. So I have 2 and then it's x. 3 minus negative 4 is actually 3 plus 4, which is 7. And then I have power 3. Okay, so question H is actually not that complicated. It looks really complicated because there's so many x's and so many y's everywhere, but we just deal with them step by step. So at the top, remember when we have two brackets that are next to each other without an operation in between them, it means we are multiplying them. So, and remember, when it comes to exponents, we can only multiply when we have the same base. That's the only rule that exists for us. So we're going to go x, and then we have to go 4 plus 3, because that's power 4, that's power 3. And then we're going to go y, and then 3 plus 5, and all over x to the power 5, y to the power 5. So when I simplify what I have in my numerator, I'm going to get x to the power 7, y to the power 8, and then at the bottom, that's just staying the same still. And now I'm going to deal with my same base division. So the power for x at the top is 7, and at the bottom is 5, which means that I am greater at the top. So that becomes x to the power 2, because 7 minus 5 gives me 2. And then y, I have power 8 and power 5, so I'm still greater at the top, and 8 minus 5 is 3. And that is your final answer.